We can just probably do the audio recording and not the video recording. We can just make the video later because we know what the slides are.
We already have it, so.
Yeah. Alright, so feature engineering. So yeah, there's just basically a bunch of data aggregation stuff now. So given that someone logged in like say 20 times, you could then say like, okay, he logged in 20 times in like some time series fashion. I'm just going to make his feature 20 instead of saying, okay, at this time step he logged in, this time step he logged in, this time step he logged in. I'd just say he logged in 20 times. Other stuff is like you can just count how many times some character occurs in a text sequence. So this is known as a bag of words kind of model, and we'll talk about that later when we get to text processing. Today is more going to be about cleaning the data than the actual methodology of how to get textual data into like a vector, into a number. That's going to be in like lecture 10 or some shit. I don't know. So yeah, also later in the class we're going to be talking about how neural nets can be used for like just like automatic feature extraction, where someone doesn't have to think about the problem necessarily, and you can just give it data and it can figure out what the relevant features are for the problem. This is great and all, but it's also why a lot of machine learning people like myself don't do too great in Kaggle competitions, because like Kaggle competitions have this unique, you need some unique insight. You need some way to be able to ground the problem in the real world. So for example, I don't know if I said this last lecture, but the way people perform the best on this Titanic dataset is they actually realized that names from like Eastern European countries were probably in like low debt classes since they came from like ghettos or whatever. So what actually people did in order to find out who survived and who didn't survive is they performed ethnographic classification on people's names to figure out where they came from, use that as a feature, and then after that threw in just the normal data of like where they were situated in the ship, whether they were a girl or a guy, and then from that they were able to get the highest performance out of like anyone on this Titanic dataset. So while like neural nets are very powerful and you'll learn to love them at the end of the course, for Kaggle datasets and Kaggle data science competitions, you still do need some innate intuition about how to ground a problem in reality, and it's actually what sets the good data scientists away from the bad data scientists. Being able to notice some pattern in the data that isn't actually in the data. I don't know if that makes sense, but yeah, being able to ground the problem in the real world. And we'll talk about that a little bit when we get to the code portion for today. So Regex is just basically the way you do this. You do this kind of like normalizing of all like your text to make all the Wednesdays, Weds, and Ws into one form. We won't necessarily be going over that 100%. We're going to be pointing you to a website to do it because just like they do a phenomenal job of teaching how to do Regex. And Regex is something just like every CS person needs to know how to do, but it's really shitty to learn. And yeah, if any of you guys take like CS 9E at some point, you'll learn to hate Regex. But at the same time, you'll learn how powerful it is, because it's really important for this data clean. No one wants to sit there and go through every fucking line and say, okay, this Wednesday it should be normalized to this form. This wedge should be normalized to this form. No one wants to do that. But with Regex, you can autonomously, normalize it to everything. Yes, Shannon?
Is there like a database of what, like say when means Wednesday, that kind of thing, where we can just substitute stuff?
What do you mean?
Appropriately, like, in order to like standardize the data, you need to convert like acronyms like WED into Wednesday. And is there like some kind of database of acronyms that we can just convert from one to the other rather than trying to think of it ourselves?
Oh, think of the do you want a database that gives you the regex to do the operation, or do you want a database of like common like normalizations, So there's no database for common normalizations, but the link we point you to has like every fucking example on how to use regex, like, or for regex in Python specifically.
Another thing is you can also have like domain-specific sort of acronyms that may not be like as common, but you still need to like go between.
Like ant might mean something to one group, might mean something to another group. Yeah, so there's no like one specific data set on like saying like, oh, these normalizations are good, these normalizations are like very standard practice. There is, however, once you think of what normalization you want to use, the website we'll point you to later today has like every single possible like regex combination on how to do that. Yeah, so don't really worry too much about knowing like or be getting really really good at and really creative about crafting regex expressions, because regex has been around since like very early computer days, so someone's already done it for you. So yeah, it's a nice thing about being a CS major. Like I know, like in other CS classes, they're like, don't copy, don't share work, don't go on the internet. That's not how shit works in real life. In real life, you're gonna be going to Stack Overflow 24/7 to figure out how to do something. So yeah, a lot of it is reusing code that already exists, especially for these super simple operations. This is just a picture of regex. Yeah, so this is just another example of how you would use regex. This is a very simple example for like detecting URLs. HTTPS and HTTP mean the same thing to us. I guess like maybe in one case, like knowing that the link is secure might be like a point of interest. But really, like we probably won't care about it too much, so we'll probably just normalize HTTPS to be HTTP. And basically, the question mark symbol means repeat the previous pattern. The bracket denotes the pattern, 0 to 1 times. And the website will go over this in much more detail. And it'll go over, like, not quiz yet, sorry. The website will go over a lot of this in a lot more detail. All the combinations of regex. Cool.
So I'll actually be making the quiz right now. So for now, get started on the assignment, and I'll let you know when the quiz is up, which should be.
Yeah.
In like
So
2
if you
minutes.
can go to, if you can just pull today's thingy.
Yeah. Wait, I don't think it's on the website yet. I don't know if Daniel did it. Yeah, it's on GitHub.
No. Whatever. I just need to get to the GitHub repo.
Yeah. Yeah, it's on the GitHub, like under, just in the day 5.
Yeah,
Yep.
and today is gonna basically be just more of just like looking at the thing. Yeah, because doing regex is not fun, and the regex will show you at the bottom is super not fun. Let me get you my laptop so you can.
Okay.
Ah, fuck. Did we not include that in the Docker image?
Did we not?
Just do pip install Seaborn. You'll get it fast.
For some reason, my read is not working. Like, I'm trying to read the CSV file.
That might be a line-ending problem. Just give me 1 second. Yeah. So go ham on this. You can also just follow along on this. Yeah, it's fine. Today's like I said, today is gonna be like the last like the tool set kind of days. So you don't need to do too much coding and creating on your own. It's mainly just gonna be looking at the example and knowing how it works in practice. So yay. The quiz though, you'll have to actually think about. Yeah, make the quiz be like a regex quiz.
Okay, alright. Yeah, wait, do you have a quick path to the MLab drive? Yeah, because I'm just gonna go use the copy of the previous course and shit.
It's down here.
Okay,
Probably
cool.
fucking. Can you favorite that star? Can you star that for me? All right. So let's just follow along and do this real quick. Okay. So first, we're gonna read this Titanic data set. It's the same one as last week. So this Titanic data set, as we saw before, has a lot of missing data points. So I'm gonna really quickly show you the difference between dropping data points and filling the data points. So if you look quickly, so if we drop all the data points that are missing, or have missing column values, in this case the missing column value is age, you can notice that we have this kind of distribution. However, as soon as you impute a value, in this case we chose like a value that's kind of representative of the distribution, the mean, since I'll get into that after I'm done talking. But yeah, so in this case we impute the mean, but as you can see, like, it skews the distribution massively. Now you have this giant spike, right? And I don't think, like, in reality that spike is there. Like, I mean, there are probably a lot of people around the age of 30, but having this huge spike at 30 is probably not actually how the true distribution of data works. So this is what I was kind of talking about, the differences between dropping data points and imputing values into data points. So yeah, this is kind of just like a visualization of what happens to your data distributions when you do that. So that's why there's also a lot of theory on how to do these intelligently so that you don't end up with these very skewed, very kind of artificial looking data sets. And the reason why we chose mean here instead of like say putting it to some concrete value like -1 or 0 is because like in nature a lot of stuff tends to follow the Gaussian distribution. Like it just does. Like a Gaussian is like a very nice distribution, and the easiest way to like describe a Gaussian is by its mean. So that's like why we just impute the mean here instead of like a hard value like -1, since even though it doesn't skew like the distribution by giving it a tail, which is probably would have happened if we put like all the values to 0, we'd have a giant spike here. Like even though it doesn't skew the distribution to one side, it kind of does give it like a giant weightage at the mean. So it does mess with the standard deviation, but it doesn't like kind of skew the data set to one side or the other. So it's kind of nice in that like it doesn't skew the data distribution, but it is messing with the true data distribution.
Wait, can you go over the definition of imputed again?
So impute just means, I guess an easy way to think of it is impute is input, right? So replace like the missing value with like so wherever there's a nan or a null or a none, you put some value. In this case, we're using dataframe.age.mean. So this takes the age column of our data frame, takes the mean of it, and imputes it, puts it into all the nan spots with this fill nan. And yeah, now we have a bunch of like, now all the missing values, all these missing ages, now have a value of 30 something. Yeah. Cool. Yeah, so now some other just visualization stuff. So this is kind of what I was talking about when you want to normalize your text data. So we do this for two reasons. One, because if we wanted to do regex, periods are kind of like a finicky value. Period is actually a special character, so you'd have to throw like a backslash period if you were looking specifically for a period. Period means like the previous value can be missing or not. That's right?
Yeah.
Yeah, okay, so it does something similar to the question mark. So that's one of the reasons why we replace it with master instead of master period. But another reason is just like they were mixing master period and master a bunch. So this is like a very simple example of regex. You manually go look for these like words and replace them. Cool. Here is something else that's very useful, group by. So this is like a command that you'll be using a lot with data frames. It basically just, as you can see, groups by this column, or groups all the rows by this column value. So there's probably like 100 different rows that have the title master, 100 different, or maybe like 300 rows that have the title mister, but you kind of just all group them into one sample point and just calculate the mean of all the value of all the columns that have, of all the age columns that have like a title of mean or of master or mister, miss, etc. Other probably was lord or count or something. I don't know what it is. But yeah, so now we're actually going to talk about something important for data frames. It's, even though it says brief aside, it's actually important. So does anyone remember on the NumPy kind of notebook how we did indexing of NumPy arrays? Yes? No? Maybe so? Okay. So yeah, so basically, so df.lock, df.ilock, and df.ix are ways to do different indexing into our data frames. So basically, you can think of this as just indexing into like a NumPy string or something. It's a similar analogy just for data frames. So basically, the way lock works is it actually goes by the rows. Or it goes by the, not by the rows, it goes by like the row index that you set. So you can actually mess with the row index. So you can do df.index.values -1. And now if you do like df.lock1, it'll give you the third row. or df.lock2, it'll give you the fourth row instead of actually the third and second row as you'd expect, since it's going off of the values that you set for the index. df.ilock is a little bit different since it's invariant to this kind of subtraction. So even if you mess with the index values, it'll just manually look at what the indices are and just go by that. So even if we had an index of -1 and that's what we'd set it to, if it's actually the first row, df.ilock0 will actually get you that first row, whereas df.lock would have gotten you the second row. Yeah. And yeah, it's literally just Python indexing, Python string indexing. That's all it is. ilock, and then ix is kind of just like a merge between the two. So if you did mess with your indices and you tried to df.lock it, but it couldn't find the value, it'll then try to, this is when you use df.ix, it'll then try and use df.ilock to just actually see if there's a row at that position that matches with the value you gave it. So that's what it kind of means by like it falls back to ilock if like the index isn't present. Cool. Okay. So yeah, so now we're going to talk about a little bit better missing value imputation. So like we saw before, like just imputing that value of 30 gave us this ridiculous spike. So what we're going to do here is we're going to first group our values into their respective into some other set of groups. Here we group by like title, and then we do our imputation based on that. Other intelligent imputations would have been grouping maybe by like your deck that you're situated on in the Titanic, because like people on the lower decks probably were younger, probably like came from harsher lifestyles, probably lived not as long, so it would have made more sense to group by that and then do your value imputation based on that.
So when you do group by, does it just group all those rows together?
Yeah. Has anyone done like SQL stuff? Yeah, it's literally just SQL group by. Okay. If any of you guys are familiar with that. Okay. Yeah, I mean like data frame is the data frame from like SQL. So it works very similarly. It has very similar notation, or very similar ways of how it's implemented. It's just Pythonic. Yeah, and there's literally ways to just like do like data frame like SQL to like, or like pandas SQL to data frame. Like yeah, pandas is just basically designed so that it can read in CSVs, it can read in like SQL tables, etc. Yeah, so this is kind of goes back to the idea of being able to ground problems in the real world. So if we look, so this guy thought first like, okay, let me group by title. In this case, he grouped by master, miss, Mr., Mrs., other. And then he was able to see that clearly each of these have different age distributions. So then he went about imputing data and imputing values on each of those like different like titles. Because like a master is like a young master. He's not going to be above 10. So if he had a missing value, giving him an age of like 30 makes no sense, right? Like, yeah, cool. We agree on that. Yeah. So this just basically goes through some nice visualization of that. It's not really too important. This is like the value count stuff that I was talking about earlier in the slides, like this kind of stuff. So value counts is just essentially just like a way of seeing like how much of each person fits into like a certain category. So in this case, it's just trying to see how many people fit into the Mr. category, Miss, Mrs., Master, other. And yeah, this is that like, so, okay, yeah, so see, this graph doesn't have that freaking ridiculous ass spike that we had before. This spike is much more like pleasant. It's like, it's much more, yeah, one sec, it's much closer to the missing value, the dropped value kind of graph.
So you're basically you're imputing based on one feature, right? The age?
Yeah, so you're imputing age, which has the missing values, it's just
or based on miss, master.
yeah.
But what if you have, say, contradictory data, like say all masters are male, but then you have a miss who's less than 10? Like say two features contradict.
Oh, okay.
Like one data point falls under two categories.
Well, see, she couldn't be a miss and a master because miss and master were in the same column, right? So unless they put her as a miss master, which isn't a thing, like yeah, then she would have fallen into other.
Yeah. Well. Okay. Yeah. Sure.
Yeah. But I think like your point though, I think it kind of relates to how like miss has this really low kind of bar here because it's basically just the female equivalent of master. I don't know, sexism, 1920s.
So does this also assume that like the value for the title column doesn't have any NAs?
Yeah, and actually the title column had no NAs.
Okay.
So yeah, if we go back to this slide, make that big. Yeah. Oh fuck. Maybe it's P class.
Probably part of name.
Maybe. I mean, it's clearly its own column in the data frame, so I don't know. Maybe they did some pre-processing on the CSV to put them into separate columns. I want to say it goes to P class.
Maybe they split the name.
Yeah, but like you want to do this missing. You don't want to be imputing values and doing this kind of grouping when there's like when you don't know a certain feature in the column, if there's missing values in that column. You kind of want to do the grouping on like something that you're 100% sure like all these values are like there is a value. Maybe there will be outliers, maybe like some of them will be mislabeled points, but at least you have like all the data points in that column. So yeah, so other like valid groupings would have been P class, maybe sex. Women live longer than men apparently.
Is there a way
fair
to automate
ticket.
like how much each feature correlates with another feature?
Yeah, so there are like some like nice libraries that kind of do that. For example, like one is like TS Fresh, which kind of does that thing for which kind of does this like feature correlation for time series data and intelligently like imputes like missing values into like your time series. There's like a lot of libraries for that. People like winning Kaggle competitions, and they like feeling good when they win Kaggle competitions and like having like a little ego power trip when they can release a nice like library to the community. Or they like being selfish and hoarding. But like there are a lot of libraries to do intelligent missing value imputation, and like I said, like imputing missing values is a huge it's a huge yet dry area of discussion. It's a huge yet dry area of academia. So there's like papers that get published like all the time on like how to do like nice data cleaning. I used to do data cleaning work, but I hated it, so I don't anymore. So TS Fresh, it's really recent and it's really popular if you do like anomaly detection kind of work with time series. Like if you're into like quant and shit, or want to get into quant, or just in general, just time series kind of modeling. TS Fresh is really good. Has like a Scala and a Python interface, or maybe it's Java and Python. I don't remember. But yeah, it has a really nice data set for. It has a really nice. It has a really nice library for extracting features, relevant features from time series data, and on top of that, imputing intelligently missing values into your time series. Yeah, it's kind of just like the holy grail of like time series data processing. Cool. All right, we're almost through this dry shit, guys. Bear with me. So here again, we see another example of being able to ground your data science problem into the real world. So this person knew, or the person that made this data set, Jerry Chen, or made this notebook, Jerry Chen, knew for a fact that when the Titanic was doing like their women and child's first kind of policy, they had actually different policies on each side of the ship. I think maybe this was due to the fact that like one side of the ship had more like lifeboats than the other. But on one side of the ship, I don't know if port is left or right, but on the port side, they only allowed women and children on board. But on the starboard side, once women and children got on board from like the upper class, guys were allowed to board those lifeboats. So yeah, and that's why like on Titanic, you see like Lord Calvin or whatever like scrambling to get to like the other side of the ship. Yeah, so this person was smart, and he basically just went through everyone's cabin information, just scrolled through it, and basically is now going to try and assign whether or not the person was on the starboard side or on the port side. And the way he did this is he knows that starboard corresponds to the odd numbered cabin values, and port corresponds to the even numbered cabin values. And he basically just creates a data frame that encapsulates this information and adds it to a column to his data set, his data frame. And then on top of this, he just looks for not null, since there were a lot of nans here, and kind of just puts them into some unknown column. So some models, like I said, can handle unknowns. The model used in this case is able to handle an unknown. It's just you don't want to leave it as a nan. You want to give it a specific category that you can then later convert to a number. So for example, this might be converted to category 0. This might be converted to category 1, 2, 3, 4, 5, 6, 7, etc. But then also we notice that there's this weird T, and then he also knew that there shouldn't be any T's, so he thought this was like an error in the data set. So what he did then is he visualized the column for T and just saw that, okay, this makes no sense, and he then went and processed manually this T to an unknown. So yeah, then afterwards he used this idea of regex, to basically parse the cabin numbers for these F things, for these F cabins, because for some reason a lot of the cabins started with F space the cabin number, and basically eliminated the F before it, and then his reprocessed the data. Cool. And then one other thing is he also noticed that some of these cabins have like C23, C25, C27. So that means he knew that certain people that booked certain tickets were in some sort of group. So then he also did some further data processing to basically assign them all a group number column. Okay, cool. We made it through some dry stuff. I'm sorry, guys. But yeah, yay, we're kind of done with like data processing, kind of. But yeah, essentially, like, there's no one way to like do data pre-processing. You just gotta be creative, think about your problem, and drop nans and impute nans creatively. And you just gotta try multiple different ways of doing this, and see which one will give you the best result for a certain model. There's really no other way. I mean, like, a good indication that you might be doing the right thing is having this distribution of imputation as opposed to this distribution. So yeah, so it basically all just will come down to data visualization and then trial and error with different models to see what imputation regime gives you the highest accuracy. Yeah, so data science is not really a science. It's more like alchemy. Yeah. Sorry about that, guys. Okay, now on to regex. I won't cover all the regex combinations since there's so many goddamn regex combinations in the world. So instead, what your quiz will be on today will basically be, you have to go to this website, regex1.com. It holds like basically every single important thing you need to know about regex, a bunch of different combinations, and yeah, answer the quiz question.
Now, if you haven't seen it, so get started on
that. And also this is kind of why I'm not covering regex. This is like the regex that someone had to do to process one data set. Like, yeah.
Is this generated or like hand typed?
No, someone hand typed that. He hand typed all those regex.
Oh shit.
So that's why like data cleaning is an imperfect science. I'm sorry, but yeah. But like I said, last of the shitty lectures. Woo! So on Monday, you'll be learning about your first ML model. So cool. Good job making it through the dry part of the class, guys. But yeah, so as you can see, like, just like real quickly, so like if you look at these values, like this is currently what they all are. They're like Simpson strong tie, 12 gauge angle. They're all these different things. He basically data cleans them down into like into some like normalized fashion. He gets rid of all the caps. He gets rid of like these acronyms, makes them lowercase. Gets rid of like hyphens. Yeah, like it's just basically he just normalized the data. And we'll talk about why you need normalized data in 5 lectures from now when we get back to text data. The next 5 lectures are going to be all on numerical data though, so you can kind of forget about regex for like 2.5 weeks.
It's on the last lecture slide.
Oh yeah, so we added it to the lecture slide.
Are you guys having issues with reading the CSV file? I feel a lot of this are happening.
Yeah, you have to change your do like dot dot data sets. Because I think those like Hamza's probably specific like
Okay. So saying I should just do this?
Yeah, I can remove the total.
yeah,
Yeah.
Remove the
I'll
total.
remove that.
Because it's relative cap.
Oh yes, true.
Alright, yeah, I think we're good to stop the recording.
So your thing doesn't spaz out.
Now that all my shit's dead, it should be okay.